We're ready to get started on Unit 7. This is Section 7.1. I can simplify expressions with exponents. Exponents right here. Now, most of this is going to be review, so let's just go ahead and get started on this. This says the product rule for exponents. We're going to use that rule in order to simplify these expressions right here. So you'll remember that when we have the same base, we can add the exponents. So this is just going to be x to the 12th. Same base. We can add the exponents, so that's going to be 9 plus 3, that's going to be a 12. Doesn't matter if one of them is negative. We'll remind ourselves of what negative exponents mean here in just a second. So we're going to add the two of those together. So this is going to be 10 plus negative 8. That's the same as 10 minus 8, so we end up with a 2 right here. Let's take a look at the next one. We've got x to the 9th over x to the 3rd. This is the quotient rule for exponents. And remember, if we're going to add the exponents when we have a product, when we're multiplying these together, when we divide, we're going to subtract. So we end up with x to the 6th here. Probably the best way to think of this one is we've got 9 x's multiplied together on the top and 3 on the bottom. We're going to cancel these 3 with 3 of those. That's going to leave 6 of them on the top. That's to me, that's a better way to think here. So again, there's 9 x's on the top, there's 3 on the bottom. These 3 are going to cancel with 3 of those, so we end up with 6. It does end up being a bit of a subtraction problem there with the exponents. And then the same type of thing here. We're going to have 4 a's on the top and 9 a's on the bottom. These 4 are going to cancel with 4 of those. That means there's going to be 5 left. So this is a to the 5th. Now, there's a 1 left on the top. There was a 1 left on the bottom here, but we don't have to write that. If the one that's left is on the top, we do have to write that. So we've got a 1 over a to the 5th. And then with a power rule here, when we've got a power, an exponent raised to another exponent, we don't raise 9 to the 3rd power, we multiply these together. So this is going to be x to the 27th here. And then we've got a power here raised to a power. This does have stuff in parentheses, but this 3 applies equally to each one of those, and technically that would be an a to the 1st power right there. So this is going to be a to the 1st to the 3rd, so that's going to be a to the 3rd. This is b to the 4th to the 3rd, so I'm going to go ahead and write b to the 12th here. Okay, so we've got those main 3 rules taken care of: the product rule for exponents, the quotient rule for exponents, and the power rule for exponents. If you have any trouble remembering how those work, one thing that you can do is you can remember how we learn the order of operations. So we learn how to add, then we learn how to subtract, then we learn how to multiply, then we learn how to divide, and then finally we learn about exponents. Well, when we're doing exponents, we don't do normal operations like this. So we always take 2 steps down, I like to say. So if you're multiplying these, if you've got a product, we take 2 steps down. That means you would add the exponents. If we're dividing, you take 2 steps down and you'd subtract the exponents. If we've got an exponent raised to an exponent, a power raised to a power, we take 2 steps down and then we multiply them. So that's one way that you can remember those rules. Let's come back over here and let's talk about negative exponents and 0 for an exponent. Remember, negative in the exponent means reciprocal. So I'm going to write reciprocal right here. So when we say reciprocal, what we mean is right now this is up in the numerator. So what we're going to do is we're going to do the reciprocal here. That negative in the exponent, just the sign all by itself, means reciprocal. So we're going to do x to the n on the bottom. So we've moved it from top to bottom. And then there's nothing left on the top, so just like we said a second ago, you have to have a 1. So if we have 2 to the negative 4, again, the negative part means reciprocal, so this is 1 over 2 to the 4th, and that would be 1 over 16 if we simplified that all the way. Again, the main goal of this is just to exercise those properties of exponents here. And then let's take a look at this one. Remember, any number to the 0 power is 1, so this would be 1, and even if we have something really ugly like this, it's also a 1. So that's pretty cool that way. Now, I do want to come back here and take a look at this one again, this one right here. So on this one, what we have here is we've got a to the 4th over a to the 9th. Now we can write that as a to the 4th minus the one on the bottom, minus 9. That would give us a to the negative 5, and then we would just use the negative property of an exponent, the fact that negative means reciprocal, to write it like this right here. I just find this much easier to think about how many factors of a do we have on the top, how many factors of a do we have on the bottom, and once we cancel, where are they left. You can do the same thing on this one. Like on this one, remember, would be x to the 9 minus 3. We subtract the one on the bottom, that's still x to the 6th. No simplifying necessary there. Okay, let's slide down here and take a look at part B. On part B, it says the following equation is true, but why is it true? So we've got 3 squared times 4 squared, and we write that as 12 squared. So why can we multiply the bases together and then keep the exponents the same? Well, there are lots of reasons for this, and the more we know, the better. So let's write down what each one of these mean. 3 squared means 3 times 3. Then we've got times. 4 squared means 4 times 4. And then here's what I'm going to do. I'm just going to rearrange these because of the commutative property of multiplication. I'm going to write this down as 3 times 4 times 3 times 4. So that would be 12 times 12, and we get 12 squared. So we get the same thing there. Another thing that we could do is instead of just multiplying each one of these together and getting a 12, saying, hey, look, I've got 2 of these guys right here. So I've got a 3 times 4. We've got 2 of those. So that's 3 times 4 raised to the 12th, or sorry, to the 2nd. So that would be 2 to the 12th. Several different ways there. We are going to come back and take a look at another way, but definitely that's true. We multiply the bases. We do not multiply those exponents there, okay, when those are the same. So let me slide down here. Now, we learned most of these rules last year. All we're going to do is apply them in some different situations. But to start with, we're just going to review some of the basic skills that you would have learned in your last class. So on this one right here, this is one big long multiplication problem. And we've got negative 62 to the 0 power. Well, that's automatically a 1. So I'm just going to go ahead and put that in parentheses. And then really we've got the 5x squared times 3x to the 7th. And when we multiply these together, we're multiplying the coefficients together, so that's going to be 15. And then I've got x squared times x to the 7th. So what I've basically done is put these numbers together. If you wanted to include the 1, 3 times 1 times 5 is 15. And then we've got the x squared times x to the 7th. And remember, when we have these two being multiplied together, bases are the same, and we're multiplying these, we add the exponents. So this would be 15x to the 9th. There's our answer on that one. And then this one's kind of a mess. If you'll take a look at this, we've got a whole bunch of stuff in the parentheses, and it's normally best to simplify what's inside the parentheses before we apply this on the outside. So we've got a whole bunch of stuff floating around here. Let's go ahead and take a look at what we get here. I'm going to go ahead and cross-cancel the 2 with the 16, so that would be an 8. And then I'm going to cross-cancel the 4 with the 8, so that would be a 2. So we've definitely got a 2 on the bottom. All the numbers are taken care of. All those coefficients are taken care of. And then we've got a q to the, let's see, 4 and q to the 5th. So that's going to be a q to the 9th. And on the bottom is a q to the 3rd. Now, we want to continue simplifying here. So what I'm going to do is I'm going to just take this and say, look, there's 3 q's on the bottom. These are going to cancel with 3 of those. So that's going to be to the 6th. So this is going to be q to the 6th power over 2. And then we're going to raise that whole thing to the 3rd power. So if we've got a power raised to a power, remember this exponent applies to the top and bottom. It's kind of like distributing it onto each one of those. So I've got a power raised to a power. We're going to multiply the exponents. So that's going to be q to the 18th. And then I've got 2 to the 3rd power. 2 to the 3rd power, of course, is 8. Hopefully we've got that one memorized. Got that problem taken care of. And now we've got this. You'll notice that we've got this expression right here times this expression. We need to apply this exponent to each one of these, and there's an important thing that goes on here. You'll notice that the negative is in parentheses. That means that exponent of 2 applies equally to the negative, the 2, the x to the 3rd, and so forth. So we have 2 negatives, that's going to make a positive. 2 2's, that's going to make a 4 when we multiply them together. Power raised to a power, so that's going to be x to the 6th. Another power raised to a power, that's going to be y to the 10th. And then we've got times 5x to the 7th, to the 7th, and then y to the 8th. And then from here on out, hopefully this is pretty easy. We're going to multiply the coefficients together, so we get 20 for our final coefficient. We've got x to the 6th times x to the 7th. That's 13 x's multiplied together. And then we've got y to the 18th. So we'll go ahead and circle that. Slide down here, take a look at the bottom. It does say right here, the problems we do today really are no more difficult than the ones that we've done in the past. We just need to adjust our thinking a little bit so we can figure them out in this new setting. One thing that people forget all the time is the rules that we learn, the product property of exponents, the quotient property of exponents, and so forth. Those work in reverse order too, and I want to show you how they work in reverse order. It's similar to question B in the warm-up. So I'm going to slide back up here and we're going to take a look at this one right here. Most of the time, and we did this when we started this, we look at this side and we try and make it look like that side. But we can actually use this in reverse. So I'm going to take this one, and instead of working this way, going that way, I'm going to start off with 12 to the second. I'm just going to write that as 3 times 4, which is a 12, and then apply that exponent of 2. So all I've done is substituted a 3 times 4 times a 12, and then each one of those is raised to the first power, and then we can apply that exponent to each one there. So this is 3 squared times 4 squared, which is where we get right back here. If you wanted to put parentheses around that, you'd be totally welcome to. Okay, so don't forget that all of these properties and all of these rules that we work with exponents, they work in reverse as well. So we'll slide down here to the bottom and let's take a look at this. It says rewrite x to the 12th using the indicated rule for exponents, and there are lots of different answers that you could get here. So let's just take a look at this one right here. This is x to the 12th. Well, one way that we could write that would be this. Let's write x to the 3rd times x to the 9th, because if we multiply these together, we add the exponents. Let's do another one. Let's say we had x to the 1st power. So I'll go ahead and write that one. And then what do we need right here so that when we add them together, we get the right total number of x's multiplied together? Well, that would be 11. So any combination, as long as these exponents combine to be 12, then we're in good shape. So I'm going to do a tricky one here. Let's do 18. If that one's 18, then the other one needs to be -6. If you multiply those together, you'd add the exponents. Any one of those would work fine. By the same token, if we've got x to the 12th and we want to do this one using the quotient rule, then we just need to make sure that whatever is on the top, so let's say we have x to the 14th, that we subtract whatever's on the bottom and we still have 12 of them on the top. So that would work there. Do a little bit of a tricky one. What if we did x to the 12th? What would we have to have on the bottom? Well, what we'd have to have on the bottom would be x to the 0. And what if we did x to the 9th? What could we put on the bottom there? Well, stop and think about it this way. If we put x to the -3 on the bottom, this would be x minus 9 minus -3. That would be +3. The other way you could think of that is if we were to apply this reciprocal idea that the negative in the exponent means reciprocal, this would be x to the 3rd when it comes up to the top, and then we've definitely got our x to the 12th there. And then if we were to use a power here, let's do an easy one. Let's say x to the 3rd raised to the, let's see, these would have to multiply to be a 12, so that would be 4. If we did x to the 2nd, that would need to be a 6. And if we did x to the 12th, what would we need to raise this to in order to get x to the 12th? It would be a 1. Again, you'll notice that in each case here, they multiply to be 12. In each case here, we take the top one, subtract the bottom one, and it turns out to be a 12. And in each case here, we add the exponents together, and it turns out to be a 12. Okay, let's flip the page over and take a look at the other side. Let's make sure we all remember that if we've got like terms, they have to have the same variables. In other words, they have to have the same base, and they've got to have the same exponent. Both of those things have to be the same in order to have like terms. So let's take a look at this example right here. This is A. The instructions say simplify. So as we kind of scan through this, you'll notice that we've got some x squared terms, and we normally do write those first. So I'm going to go ahead and write that as, let's see, this is going to be 7x to the 2nd. Done with those, and I like to cross those off so I know I've used those. I'm done with those. Let's see, 2x minus 5x. That's going to be -3x. Again, done with those. And then we're going to write the constant at the end there. Finished up with this one. The one next door is A star, and the reason it's got a star by it is some people lose track of this and they think, oh, all I'm looking for is I'm looking for the same exponents. That's not what we're looking for. They've got to have the same variable and the same exponent. So there's only one of these x squared terms, so I'm going to write 4x squared. There are still these two plain old x terms, so 2x minus 5x is -3x. Done with those. And then we're down to these two. Now, there's not really a good order to write these in. I'm going to go ahead and write the constant here and then the +3y squared at the very end. There is no good way to write it. If you wanted to write the y squared right up here with the x squared, as long as we move those terms around and keep the signs in front of each one of them, that would be just fine. I'm going to go ahead and leave it like that. And then we get to this one right here. This is a distributing problem, so I'm going to go ahead and distribute through here. So this is going to be, let's see, 5x times 2x squared. The coefficient's going to be 10, and then we're going to have x to the, remember that's to the 1st times x to the 2nd. We add the exponents together. If we multiply here, this is going to be negative 5x squared. Remember, x times x is x squared. And then 5x times 1 is going to be 5x. Now, the reason we don't multiply this 2x squared by the 5x is it's not in the parentheses. It's only 5x times that stuff in parentheses. So we're going to put plus 2x squared. And then really the only simplifying that we can do once we get rid of the parentheses is just combine those like terms right there. So this is going to be negative 3x squared and then plus 5x. We'll go ahead and circle that, and then we'll take a look down here. This is where it starts to get a little bit interesting because you probably haven't done problems like this before. Remember, they're like terms if they have the same base and the same exponent. So just like we had negative 5x squared plus 2x squared, and those were like terms, take a look at what we've got here. We've got 10, 2 to the x, minus 3 times 2 to the x. So this 2 to the x stuff is just like the exponents, just like these terms right here where we've got x to the second here, except the x and the 2 have changed places. So these are still like terms. So what I like to do is think of this way. This is 10 of these things right here minus 3 of these things right here would give us 7 of those things right there. Now, that same logic applies to the ones that we did up above. So if we take a look at this one right here, I've got minus 5 of these things right here, plus 2 of these things right here, gives me negative 3 of those things right there. Okay, let's run through and take a look at this one right here. You'll notice that we do have some like terms there. So I've got 4 of these plus 3 of these. See how easy that kind of rolls off your tongue as opposed to 4, 6 to the x plus 3, 6 to the x. 4 of these plus 3 of these is 7 of these. So I'm going to go ahead and put it like that. Now, it really doesn't matter if you put the parentheses around the 6 or the x. You've just got to have them there so nobody writes this, because then somebody might look at it and say this is 76 to the x. Okay, so we don't want to do that. All right, so we've got those two taken care of, and then I'll write the plus 5x, and then I'll write the plus 2, and we are all set moving along here. See, it's really not too bad. Now, when you get to this, you might be tempted to say, oh, I'm just going to add these together, but remember, this is a different operation. The little dot there means multiplication. So just like we would do if we had the 2 of these multiplied together, we multiplied the coefficients together and we got 10. We're going to multiply the coefficients together and we're going to get 12. And then we've got 4 to the x times 5 to the x. And remember, on the other side, we can multiply the bases together and the exponent's going to stay the same. So this is going to be 12, and this is going to be 20 to the x. This right here is the answer. And if you want to stop and think about why, we could do a couple of things. We could write down 4 times 4 times 4 times 4 times 4 x times, and then we could write down a whole bunch of 5s. X times, okay, we don't know how many times that x is, but then I multiply these together and I've got 20, multiply these together and I've got 20, and so forth. All the way along I'd have x of those multiplied together. Another thing that we could do is we could just pull these exponents off here and say, look, they're both raised to the x, so I'm going to have 4 times 5 to the x, so that would give me 20 to the x. Okay, a couple different rationales for that right there. And then by the same token, if we take a look at this next one here on example F, we've got a division problem on this one, so we can go ahead and cancel the 2 with the 4. That leaves a 2 in the denominator, so we definitely have a 2 down here. And then I have 21 to the x over 7 to the x. So down here I'm going to pull that x out here, and we're going to have 21 over 7. So we're kind of using that quotient property backwards. Instead of this applying to both of these here, we're basically pulling it out here, leaving it on the outside. So we've got 21 over 7, and we can cancel those. That's going to be a 3, so this is going to be 3 to the x. And then on this one, you'll notice I've got a star by this one. This one's a little bit weird. This is actually a Greek letter alpha. If I've got alpha to the x over alpha to the x, that's the same thing over the same thing in a multiplication problem and division problem. So I can go ahead and cancel those. So after all of this, I've just got 20 over 10, so we can cancel those, and we end up with a 2, plain old 2 there. And then let's take a look at this one right here. We multiply those coefficients there, we're going to get a negative 6. And then for some reason, some people will look at this and they'll do weird stuff. They'll say, oh, well, those make a 10 or something like that. They don't. Just like up above when we were multiplying these together, we're going to multiply those together and we end up with 25. So I'm going to go ahead and circle that. Now, there is another way, and I want to show you how to do this one. And you don't need to write this down. I just want you to think about it for a second. This would be negative 6. And then if I were to multiply these together, notice that they have the same base, so we could add the exponents. So this could be 5 to the 2x. And then this might get a little bit complicated, but remember, this would be like a multiplication problem. So we can change this. We can use the power property backwards, and we can say, look, I'm going to make this a multiplication problem by putting the x on the outside, and I'm going to leave that 2 on the inside. And then 5 squared would turn into the 25. So I've got negative 6, 25 raised to the x. This is the same thing either way. Definitely easier if you catch it that way, though. Now, there's a little thought question down here before we get to the self-assessment. What do we do if nothing can be simplified? So let's say we ran across something that said 4 to the x times 5. Well, we can write simplified, and then we'd want to make sure that it's written in the correct order. Now, when we say the correct order, normally we write coefficients out front. So we'd write 5 and then maybe a dot to the 4 to the x, or we write 5 and then parentheses 4x. Or if you want to, the way this has been shown sometimes on this, parentheses, that shows that that is the base, and then we raise that to the x. All of these would be the same thing. All right, go ahead and do the self-assessment, and then good luck on the assignment.